Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So let's start with our kuliah, which we stopped at cleaning data with R. So we continue with analysis of variant ANOVA. This is our reference book. Okay, now, as an introduction, when part 2 are included as explanatory variable, our focus usually shift from prediction to understanding group difference, and the methodology is referred to analysis of variant. Okay. Here, ANOVA methodology is used to analyze a wide variety of experimental and quasi-experimental design. Okay, this chapter provides an overview of R function for analyzing common research design. Okay, in here we use R to analysis some example. Okay, let's begin with okay, here we use R and we install the package car, gplot, rrconf, and mb outlier in our example. Okay, and be sure to install them before trying out the sample code. Okay, the sample code is the thing that I put in the ULearn, which is analysis of variant V3. Okay. Here. Wait, Okay. Okay. This is the terminology of this chapter. Okay. Experimental design in general and analysis of variant in particular has its own language. Okay. Before we analyze, okay, this design, okay, we have to do some review on important term. Okay, we have to know some important term first. Okay, you are interested in studying the treatment of anxiety. Okay, this is our case study, which is to study the treatment of anxiety. Okay, two popular therapies for anxiety are cognitive behavior therapy, which is CBT, and another one is movement desensitization and reprocessing, which is EMDR. Okay, this is two different therapy, and you recruit 10 anxious individuals and randomly assign half of them to receive 5 weeks of CBT and half of them to receive 5 week EMDR, which is from 10 sample we divide into 5 who receive therapy CBT and another 5 is EMDR. Okay, at the conclusion of therapy, each patient is asked to complete the state trait anxiety inventory. Okay, and a self-report measure of anxiety. Okay, this is at the end of therapy session. Okay, in this design, treatment is between two group factor, which is two level. Between two group, which is one who receive CBT and another one who receive EMDR. Okay, it's called a between group factor because patients are assigned to one and only one group. Okay, just now from the 10 sample we assign 5 into CBT and 5 into EMDR, which is one and only one group. Okay, no patient receive both between CBT and EMDR. Then this assessments SDAI is dependent variable and the treatment is independent variable, which means this is the independent, it will cause the STI later on, which is like an example in the equation. Dependent is Y. Y is STI. Y is STI is equal to the independent variable, which is the CBT and EMDR just now, the factor. Okay, because there are an equal number of observation in each treatment condition, we have balanced design. Okay, when the sample size are unequal across the cell of design, you have and unbalanced design. Okay, here in table 9.1 is called a one-way ANOVA because they are single classification variable. Okay, specifically is one-way between group ANOVA. Okay, this is table 9.1. 9.1. Okay, effect in ANOVA design are primarily evaluated through F-test. Okay, if the F-test for treatment is significant, you can conclude that the mean STAI score for two therapy differed after 5 weeks. Okay, we have to measure whether this is the significant or not. The treatment is significant or not from their F-test. For the that you can conclude that the mean STAI score for two therapies differed after 5 weeks. Okay, if you were interested in effect of CBT on anxiety over time, you could place all 10 patients in CBT group and assess them at the conclusion of therapy and again 6 months later on. Okay, this is where we put it in table 9.2. Okay, this is 9.1. We separate the 10 people just now who received CBT and EMDR. This is what we call one-way between group ANOVA, one-way between group. And this is one-way within group ANOVA, which is we continue with 10% using one particular treatment, which is CBT just now. And we monitor 5 weeks and another 6 weeks. This is what we call within group. Okay. Time is a within group factor with two levels, 5 and 6 months. It's called within group factor because each patient is measured under both levels. Okay. The statistical design is one way within group ANOVA. Okay, because each subject is measured more than once, the design is also called repeated measure ANOVA. Okay. Because of we measure by using CBT just now. First is in a 5 week and second is in a 6 month. Okay, if the F-test for time is significant, you can conclude that patient mean STAI score change between 5 and 6 months. Okay, this is the further definition or further explanation for F statistic or F value. Okay, this is way how we can interpret ANOVA test. Okay, this is low discriminant between group. And this is high discriminant between group. Just now the example is between group is the 5 using followed the CBT treatment and 5 followed the EMDR. We separate these two group into different treatment. This is what we call between group. Okay, this is where the low discriminant look like. And this is where the high discriminant between group look like. Okay, and this is within group. Okay, this is high level variance within group. And this is low level variance within group. It's more shrink here. Okay, then if you're interested in both treatment, different and change over time, if you want to do it both treatment, just like the between group just now, but we want to know its change over time. Okay, you could combine the first two study design and randomly assign 5 patients to CBT and 5 patients to EMDR and assess them their STAI result at the end of therapy and at 6 months C table 9.3 after this. Okay, like this. Okay, we separate the treatment and we want to know its over time. First in 5 weeks and second is in 6 months. Okay. By including both therapy and time as a factor, you are able to examine the impact of therapy average across time average across therapy, and the third one is interaction between therapy and time. Okay, the first two are called main effect, and whereas the interaction is not surprisingly called interaction effect. Okay, this is okay. We call that the time and the therapy is the main effect, and the interaction effect is from the therapy and time. Okay, when you cross 2 or more factor, you are done here. You have a factorial ANOVA design. Okay, Crossing two factor produce a two-way ANOVA. Crossing the three factor produce a three-way ANOVA, and so forth. Okay. When a factorial design include both between group and within group, it's also called mixed model ANOVA. Okay, the current design is two-way mixed model factorial ANOVA. Okay, here we have three F tests, which is one for the therapy and one for the time just now and one for the interaction between therapy versus time. Okay, a significant result for therapy indicates that CBT and in EMDR differ in their impact on anxiety. Okay, this is significant for therapy. And we from the F test, if we see the significant result for time, is indicate that anxiety change from week 5 to week 6. Okay, and if it is significant for the interaction, it indicates that the two treatment for anxiety had a different impact over time. That is, the change in anxiety from 5 weeks to 6 months was different. Okay. Yeah. Okay. Here is the table for two-way factorial. Okay, this is two-factor ANOVA with one between group. This is one between group and one within group factor. This is patient over time within group factor. Okay, now let's extend the design a bit. It's known that depression can have an impact on therapy, and the depression and anxiety often co-occur. Okay, even though subjects were randomly assigned to the treatment condition, it's possible that two therapy groups differed in patient depression level at the initiation of the study. Okay, any post-therapy difference might then be due to the pre-existing existing depression difference and not to your experimental manipulation. Okay, because of depression could also explain the group different on the dependent variable. Is a co-founding factor, and because you are not interested in depression, it called nuisance variable. Okay. If you recorded depression level using a self-report depression measure such as the back depression inventory when patients were recruited, you could statistically adjust for any treatment group different in depression before assessing the impact of the therapy type. Okay, in this case, BDI would be called a covariate, and the design would be called an analysis of covariance, which is ANCOVA. Okay. And finally, you recorded a single dependent variable in this study, the SDAI. Okay, you could increase the validity of this study by including additional measure of anxiety such as family rating. Okay, we want to know another thing, which is family rating, therapist rating, and a measure assessing in the impact of anxiety on their daily functioning. Okay, when there are more than one independent variable, that the design is called multivariate analysis of variant, which is MANOVA. If there are covariate present, it called multivariate analysis covariance, MANCOVA. Okay, the explanation you may found here. Okay. Fitting ANOVA model. Okay. Here we want to do a fitting of ANOVA model. Okay. Although ANOVA and regression methodologies developed separately, functionally, there are both special case of general linear model. Okay, we could analyze ANOVA model using the LM function used for regression in chapter 7, which is regression. Okay, here we primarily use AOV function in this factor, analysis of variant. The result of LM and analysis of variant AOV are equivalent, but the AOV function present this result in a format that more familiar to ANOVA methodologies. Okay, for completeness and experiment using LM, at the end of this chapter is also provided. Okay, the AOV function. Okay, the syntax of AOV function is AOV, okay, in a bracket formula and the data frame. Okay, and at the 9.4 table describes special symbol that can be used in the formula. In this table, Y is the dependent variable and the letter A, B, C is representing the factor. Just now, if you look at the example of the uh, treatment for anxiety just now, Y is the STAI, A is the therapy, B is a time, and C is the interaction between therapy and time. Okay, this is the special symbol used in our formula, which is here is separate response variable on the left from the variable on the right. For example, here, this is dependent and this is independent. Here, the symbol for separates. Okay, plus is separate explanatory variable. And here, we can look at plus here. For the variable, it's separate from A to B and to C. Okay, and double dot here is denote interaction between variable. Okay, if we have interaction between A and B, we put A double dot B. Okay, and star here denote the complete crossing variable. The code A star B expand to, okay, this is the crossing, the completeness. We no need to put one by one like this, but we only just to put star and it represent all the interaction and all the factor here. It's like a factor and this is a expand from this simplify method. Okay, then here is denotes crossing to specified degree. Why? Separate here A plus B plus C and power of 2 expand to here. Which is expand to degree 2. Okay, and here dot a placeholder for all variable in the data frame except the dependent variable. For example, if the data frame contain the variable y, a, b, and c, the code y separate dot here is will expand to a plus b plus c. No need to put all the factor, but it can count for a plus b and c by putting dot only. Okay, this is the formula of one. This is the formula where the one-way ANOVA. And this is one-way ANCOVA with one covariate. Here, X is a covariate and this is one-way ANCOVA. Okay, two-way factorial ANOVA. This is two factor. And when we have the covariate, okay, two covariate here with two-way factorial. And this is what we call randomized block. B plus A, where B is blocking factor. And one way within group ANOVA, it is like this, A plus error from subject divide by A. Okay, and want to find the repeated measure ANOVA with one within group factor and one between group factor B. Okay, just put it like this. Okay, when we put a within group, okay, which is we have to put error subject divide by A. Okay, for here within group factor W, subject divide by W, error. Okay, then the order of formula, the order in which the effect appear in formula matter when A, there is more than one factor and the design is unbalanced, or we have to put covariant are present. Okay. When either of these two conditions is present, the variable on the right side of the equation will correlate with each other. In this case, they know ambiguous way to divide up their impact on the dependent variable. Okay, this is example in two-way ANOVA with unequal number of observation. Okay, in the treatment combination, the model Y separate A times B will not produce the same result as Y separate B times A. Okay. By default, R employ the type 1 sequential approach to calculating ANOVA effect. The first model can be written out as this: Y is equal to A plus B plus A interaction with B. This is the two factor and this is between two factor interaction. Okay, the resulting R table will assess the impact of A on Y and the impact of B on Y. Okay, this is what the result will be, which is the impact of A and the impact of B and the interaction A and B, controlling for the A and B main effect. Okay, so here for the ordered count, when independent variable are correlated with each other or with covariate, if we put covariate there are no ambiguous method for assessing the independent contribution of this variable to the dependent variable. Okay, consider an unbalanced two-way factorial design with factor A and B and dependent variable Y. Okay, there are three effects in this design. The A and B main effect and A times B is the interaction. Okay, this is the formula. There are three typical approach for partitioning the variance in Y among the effect on the right side of this equation. Okay, the greater the imbalance sample, the greater the impact that the order of the term will have on result. Okay, in general, more fundamental effects should be listed earlier in the formula. In particularly, covariate should be listed first, followed by main effect, followed by two-way interaction, followed by three-way interaction, and so on. For main effect, more fundamental variable should be listed first. Thus, gender would be listed before treatment. Here, the bottom line, when the research design isn't orthogonal, that is when the factor and or covariate are correlated, be careful when specifying the order of effect. Okay, before moving to the next specific example, note that ANOVA function in the car package in a R not to be confused with standard ANOVA function to provide the option of type 2 and type 3 approach rather than type 1 approach. Okay, rather than type 1 approach used by the AOV function, you may want to use ANOVA function if you are concerned about matching your result to those provided by other packages such as SAS and SPSS. Okay, here you may see in ANOVA package CAR for detail. Okay, now one-way ANOVA is a one-way ANOVA. You are interested in comparing the dependent variable mean of two or more group defined by categorical group factor. Okay. Our example come from cholesterol data set from Markholm package and taken from Westfall Tobiarom H. Hochbeck 1999. 50 patients received one of 5 cholesterol reducing drug regimen. Okay. 3 of the treatment condition involved the same drug administered as 20 milligram once per day, one time, and another is 10 milligram twice per day, two time, or 5 milligram 4 times per day. Okay, two remaining condition, drug D and drug E, represent competing drug. Which drug regimen produced the greatest cholesterol reduction response? The analysis is provide. Okay, so let's do it in R. Okay, in R, later on, okay, you have download the lab ANOVA V3, just double click and choose RStudio, and it's already in your script here. And here you may run this. Okay, first we have to run Malcolm because the dataset in a Malcolm. Let's wait a bit. Okay, after finish with the install package, let's find the library Malcolm and then attach the cholesterol. The cholesterol just now, the table. TRT, table TRT. Okay, here. 10 for one time, 10 for two time, 10 for four time. And there is drug D and drug E. Okay. Here is the head of our cholesterol table. Okay, it's like this. And this is the treatment, TRT, and this is the response. Okay. And the first thing, of course, from the one time, because there is 10 sample for the because the heat will only show the beginning six item, right? So for the cholesterol itself, if you want to look at all the data for the cholesterol, okay, like this, for the treatment 10 treatment, and this is the response to treatment, and this is the response, and so on, and for the drug D and drug E also. Okay, here aggregate. Okay, just now we call the cholesterol table, and this is the aggregate mean. Okay, group mean. Okay, this is the mean for the group one time, two time, four time, and for the drug D and E. Okay, looking for, okay, just now, the output you can see 10 patients receive each drug and regimen like this, 10 group punya response for time until the, one time for the 10 group, two time for the 10 group, until four time for the 10 group. This is the response for number one. Okay, and this is the, from the mean, it appears that drug E produced the greatest cholesterol reduction, whereas one time produced the least. Okay, one time produced the least, and drug E produced the greatest one. Okay, let's go for the next is standard deviation. Okay, aggregate response list of treatment and function is standard deviation here. Okay, standard deviation were relatively constant across the five groups. Ranging is between 2.88 to 3.48. Okay, the lowest one is 2.88 and the highest one is 3.48. Okay, now this fit. Okay, let's run it. Fit ANOVA, and we want to know what is the fit analysis of variant for the response of TRT. Okay, treatment of response for the treatment, and this is the summary. Okay, you can see this. Okay, what we want to analyze here is the ANOVA F test for treatment TRT is significantly less than 0.001 here, providing evidence that 5 treatments are all equal effective. Okay, then for this library gplot, we run it because we don't have it yet. So we have to run the library and plot mean. Here we want to plot group mean confidence interval. Okay, and here we can see here the plotting graph. Okay, here. The plot means function is G plot package can be used to produce a graph of group mean and their confidence interval. Okay, this is the N, which is 10. Sample 2 time is the for the 10, which is here. Okay. A plot of treatment mean with 95% confidence limit is provided in figure 9.1. Okay, this is the okay, this is the figure. Okay, and allow you to clearly see this treatment different. Okay, from here you can see beside we have like this the different of mean and value for this. We may see it in a graph here. Okay, the different. Okay, and let's go to our slide back. Here, just now is one way ANOVA, and this is the uh, result for the significant test just now, right? And let's go to the, okay, this is the thing that I explained in a R just now, and this is multiple comparison. Here, ANOVA F-test for treatment tell you that 5 drug regimen unequally effective, but it doesn't tell you which treatment differ from one another. You can use multiple comparison procedure to answer this question. Okay, to know 5 drug regimen unequally effective, but it doesn't tell you which treatment differ from one another. Okay, for example, Turkey HSD function provide a test of all pay, which is in a listing 9.2 here. In a listing, okay, let's do lab in R. Okay, in a note here that Turkey HSD function has compatibility issue with package HL or HS, also used in this chapter. HS is loaded. Turkey HSD will fail. In that case, use detached package the HS to remove it from the search bars and then call Turkey HSD. Okay, let's do it in R. Here, we want to know the Turkey HSD here. We feed it. Run. Okay, here, Turkey HSD feed. Okay, if you can see here, a analysis of variant formula is equal to respond with the treatment. Okay, this is the treatment. And let's run. Okay, here is the par LAS is equal to 2. Okay, then plot Turkey HSD. Okay, this is the plotting. Okay. Okay, here the mean cholesterol reduction for 1 and 2 times are significantly different from each other, which is P is 0. P just now is 0. What is it? P is 0.138 here. Here, the P value, the P is 0.138. Whereas the difference between 1 and 4 times is significantly, which is less than, this is the difference between 2 and 1 time is 0.18, and but for the 4 and 1 time is less than 0.01 here. And then the pairwise comparison are plotted in this figure. The first bar statement rotate the axis label, and the second one increase the left margin area so that the label fit, which is far option are covered in previously. In this graph, confidence interval that include 0 indicate treatment, that are significantly different, which is P is greater than 0.5. You can see that here, if greater than 0.5. Okay, this is the p-value between 2 and 1 factor, 4 and 1 factor. You can see. Okay. And this is where the lower and upper, and this is the difference. And the GLHT function in the Markov function package provide a much more comprehensive set of methods for multiple mean comparison that you can see for both linear models such as those described in here, and generalized linear model, which is previously later on we will cover in the next lecture. The following code reproduce the Tukey HSD test along with different graphical representation. Okay, if you want to do a different graphical representation, okay, like this. Wait, here. Okay, here. This is library Markov. We run it first, and okay, this is the Tukey, and we want to plot it in a different way. Okay, we get the box plot here. What is mean? Okay. Yeah. Wait, Hmm. Okay. Okay, in this code, the par statement increase the top margin to fit the letter array. The level option in CLD just now, CLD function provide the significant level to use 0.05 or 95% confident in this case. Okay, group represent by box plot that have the same letter don't have significantly different mean. Okay, you can see that 1 and 2 time are significantly different. 1 and 2 time. 1 and 2 time is significantly different. Okay, they both have the letter A here. They both have the letter A. Okay, and 2 and 4 time, it is insignificantly different because they both have, okay, insignificantly different because here, they both have the, okay, 1 and B just now is also not significant different because they both have a letter A, and 2 and 4 are significantly different also because they both have letter B, but 1 and 4. 1 and 4 here, it is different. Okay, 1 and 4 are different. They don't share a letter here. 1 only have A, and 4 time only have B and C. Don't share a letter. Personally, this table easier to read than previous table just now. Is also have the advantages for providing information on the distribution of score within each group. Okay, from this result, you can see that taking the cholesterol lowering drug in 5 milligram does 4 times a day much better than taking 20 milligram dose once per day. The competitor drug D wasn't superior to this 4 times per day regimen, but competitor drug E was superior to both drug D and all three dosage strategy for our focus drug. Okay. Multiple comparison methodology is a complex and rapidly changing area of study to learn. Okay, then we may see the slide. Okay, this is what we do just now. Okay, first graph that we plot and the second one. And the second one, we can see whether it's significant or not. If it is different because it not share the same letter, like 1 time to the 4 time here. Okay. Okay, I think that we have to stop in assessing test assumption. Then we go to the part 2 later on. I will record later in the assessing test assumption. Okay, good night, good luck and take care. Assalamualaikum and salam sejahtera.